Amazing. So here we are over on YouTube now instead of Twitch. We'll see how that goes. I'm just getting everything moved about. And then we'll get going. Let's just make sure everything's there. Cool. Here we go. So what we're going to carry on doing is making the physics vehicle. And we're going to do that. You might hear some coughing in the background because my daughter's sick home right now. It's going to just carry on with the physics vehicle that we were working on the last few streams. I think this is going to be the last stream that we actually do for the physics vehicle, purely because I'd rather focus on smaller things, particularly only streaming once a week, smaller stuff that's easier to put together, that doesn't take this kind of multiple streams of fiddling about with small details to do, so more like bigger impact things that people can learn from. And so that's what we'll be doing. I'm taking suggestions in Discord if you have ideas for things you'd like to see. So that should be cool if people get in there and just throw some ideas out. I have a list of ideas of my own right now. And then the other thing we're going to do that Ashley's brother suggested is to just show what we're currently working on. So I'm just going to add that now. Just a little bit of text. Current task. Wow, that's enormous. What is a current task? So going to be making turning better, essentially. And that's in, so I guess you'll probably be able to see that now and watch me resize everything. And now it's upside down. That's not super useful. Let's see. Let me know if white isn't like a great color. Just going to flip back to the stream and take a look at it from this side of things. Seems okay. Yeah, so what was the problem with turning as it is right now? Well, you go over here and you get in, and that's not the driver's side to get in. So right now you basically do two things. You can see with the keyboard I just flip straight to sideways, and that's pretty jarring. It'd be nice if there was some smoothing of that. And then the other side of it is that, like, when I'm not moving at all, I just sort of skate round in circles. So we want to fix really both of those things. What would be nice is if it mimicked like a vehicle. So like a car doesn't turn unless you're moving, because the wheels are in contact with the ground, and it's the friction with the ground or the wheels being like physically turned that moves the car. And an airplane doesn't start turning until it has enough airflow over the different control surfaces to make you turn. And so I think like that model is pretty good. Like you could think of this like a boat that has thrust vectoring, like bow and stern thrusters that let it spin around in circles. We're also in a different medium there, like water's a lot denser, and kind of like that control makes more sense from the way you're able to like understand in your brain like what makes sense for what's happening. So we're gonna do this like an airplane. So going faster lets you steer better, essentially. And to do that, we're just going to grab our physics vehicle code, which we haven't looked at in a while. And I think that's one of the other reasons I want to start doing some other things, because like this was cool when I was just doing the physics stuff and it was self-contained, whereas like doing a lot of other things is not. So we'll see how that goes. So just to remind everybody how it's set up, we have two particles. They're connected together by a spring, and there's two springs going to the ground which act as the suspension for the vehicle. And then the actual object is lined up along the vehicle. And the way we move it around is we work out what the controls are and apply some forces to the particles. So for steering, we have this steering force here. If we go down to the tick, we can see we work out what the steering force is based on the current stick input. And then in our little kind of deterministic, we're going to call this exactly 60 hertz code. We're just adding the steering vector to particle A and particle B in the opposite direction. So it's sort of spinning it around the center of those two particles. And so what I want to do is base it on the stick, but also base it on how fast we're going forward. So there needs to be like a component of that as well put into things. So we'll find that first. What we need to know is like, how fast are we going? How fast is the particle moving? And that sort of thing. So we'll take one of the particles. In fact, we should do this within the within this loop here. So we've got the can rename this to control steering force. That's more what it is. And down in here, we want to get out our particle's velocity. And in fact, we only want its speed, really. Although we do want the velocity because we want the direction it's going in. It's an interesting one. Is it going forwards or backwards? We'll start off with like particle. Yeah, so we've got the facing direction here. That's cool. That's what we need. Although we're now getting rid of it. So we want to clone that. And we want also, yep, I think we can just use our facing direction. Let's just see where we're using it. I'm just worried about like whether we're, yeah, so it's the normal direction that we're facing in. So the particle speed we're going to work out has got to be this dot particle A dot velocity, and that's a vector 3. And we just want to get its length. So that's giving us its speed, but that can also be that'll always be positive. So if we're going backwards at a high speed, then we won't get the right value out. So what I want to do is do the dot product of the particle's velocity with the facing direction. And then we'll get a value that we can use to decide which way we're going. So particle dot facing. So just doing that. So what we're going to get out is if the two things are quite close to each other, it's going to be above 0. If they're facing away from each other, and we probably we want to normalize this as well. So it's a lot of cloning going on. This is making temporary vectors that will get thrown away every single time this is called. So at some point it'd be good to go through and collect them back together again. Just get rid of them, put them into a temporary value. So we're getting the dot product. And so we can say the particle velocity is the velocity dot facing greater than 0. We'll just do the velocity or 0. So that's our current particle speed. So if we're going backwards from our facing direction at all, then we'll just zero out that value. Otherwise, we'll just use the particle's current velocity. So that also means that when we're turning, that velocity will be slightly higher because the particle's moving sideways as well as forwards. We could, as an alternative, project the velocity onto the facing direction, and then we would be using the component of the velocity in the facing direction. But I think for we're making a very straightforward model right now, so we're not going to go that far. Maybe we'll do that in a bit and see what the difference is. We've got the particle speed, and now we want to work out a value that particle speed should be use that. So we want a minimum speed for turning for when turning starts and a maximum speed for when turning is at its largest. Steering min speed. So what have we got here? We don't really have any speeds in here right now. So let's say like a minimum speed just to start off with of 100 and a max speed of 500. I don't know if these are sensible values. Maybe we did add a speedo. Maybe we'll add a speedo into this version so we can just sort of see what's going on. Min speed, max speed, we can log out the speed as well just to see what's happening. And so what we want to do is we want to take the current particle speed and kind of transform that into a range of 0 to 1 to say how much steering there should be. And so what we're going to do is called speed turning factor, I guess. And so we've got the minimum speed. So if we get the particle speed and we take away the minimum speed, and then divide it by this dot maximum speed minus this dot minimum speed. So this is saying, okay, we've got the particle speed and we're going to remove the steering speed from it. And if it is, and then we're going to put it into the range that our max speed and our minimum speed are in between. So if particle speed is above our minimum speed, then it's going to be a number greater than 1. If it's less than our minimum speed, less than the minimum speed, it's going to be a negative number. And if it's in between our minimum speed and our maximum speed, then it's going to be between 0 and 1. And so that's cool, but we don't want that behavior where it goes negative below the minimum and positive above the maximum. So we'll just clamp that. So let's turn that to a let instead. And we can just use our math utils clamp. We've got our value, which is the speed turning factor. Our minimum number is 0 and our maximum number is 1. And then our steering force vector becomes our control steering force, which is the control factor mixed in with the steering force multiplied by our speed turning factor. So now if we save that, we can see if it works, and if not, debug why. Let's just close you down. I think our ship fell off the side of the thing. So we'll get in anytime you feel like it. And so we can see we're doing definitely the side-to-sidey bits now. And we can see that the speed thing is kicking in. So we need to stop the sidey just now. Let's just disable that for now so we can see in isolation what's happening. Which is our rotation, pitch, rotation. Where's our roll? This is where we're setting it up. So if we get rid of this, and then we can play again. So we get in and we bounce against the vehicle, which is kind of unwanted, really. In that regard, I guess the collision isn't being disabled at the right point. You can see I'm pressing. We can't see. I'm pressing the left and right keys right now, and nothing's happening. If I accelerate, then you can kind of see I can then start turning. It obviously doesn't have the roll on there. Whoops. And then we'll fall off the edge of the level. So that's cool. I want to extend this to the roll as well. So we need the roll back on. And what would be nice is to have this speed turning factor outside of this loop. So the last value of it is what we can use for our roll. So we've got a few things outside already. Let's just define the speed turning factor here. And it's going to be 0. If it doesn't get set in the frame, it's going to be 0 when we get out here. We already have the stick X in here, so that's the stick turning factor. So we just need to multiply our speed turning factor in here as well. So we can only hit our maximum roll when we're over that limit. Or at least that's the idea. And let's try it again. Get in. So yeah, we can't turn and we're not rolling. We're going faster. I have not turned something on because we're no longer rolling at all. Maybe the last frame is 0. Let's see what's happening. I didn't need to stop that actually. So we are trying to say what the current roll is. So the only thing we added was the speed turning factor in there. It gets set to 0 out here, and then we redefine it. Okay. So here's the problem. With the let in there, we're creating another locally scoped version of this, not setting, and it's kind of shadowing this one. It's making it not visible. So now this should work. So we're in. It's not really doing anything. We'll spin around. And now we have basically the same behavior as before. You can kind of see, that oh, we got stuck in the ground. Something odd's going on with that collision. That was working last time. You can kind of see that it does go as we go faster. It's got like that nice lerpingness to it there, which is cool. But obviously as soon as we hit the maximum, it just flicks from side to side using the keyboard input, which isn't so nice. So there, I don't think we've necessarily got great values in that. Or maybe they're okay. So you can spin yourself like that, which is quite fun. I think you want to get steering force quite quickly. So you can see how you can't steer right now. And then as soon as I start going, quite quickly goes up to the maximum. So maybe that max value needs to be higher. Let's say like 1,500. That seems really high. But let's play it and find out. So now if we thrust forwards, we can only turn a little bit. We're never getting anywhere near that maximum though. So yeah, let's log out just how fast this car is going so we can see a little better what's happening. Do it here. And just log out the length of that whilst we're driving around. Get rid of the code. Right, let's open this up. So we can see it's 30. When we start driving, so like 300 is maybe a place to start. Well, maybe not. So we can get as far as, whoa, we can get as far as 800 there. That is, wow. Goes to infinity. We should debug that as well. That could be an interesting thing to look at. Because that's a new behavior that's crept in from somewhere. So 1,500 is much too much. So steering should be at the maximum when it gets above like 600, I think. And 100 was a good like minimum amount as well. You can kind of see that coming in. Let's save that. Yeah, so this is happening in collision stay. So that's fine. And I'm just looking through. Yeah, so we've got that rolling happening. And the next thing it would be cool to do is to make that rolling itself look essentially. So we've got a target roll and a current roll. And this is just a value. So we just want a value in here. Current roll, it can be 0. And where are we at down in here? So this is going to be our target roll. And we can have a roll rate down in here. And it's got to be in radians, math pi divided by 4. You want it to be slower than that. Divided by 16 to start off with as a value. And so want to know which way we want to go. And so we've got our current roll. So we've got our current roll minus our target roll. And then we can do math.sign. And that tells us what the sign of it is. So if our target roll is larger, we're doing this the wrong way around. Target roll minus this current roll. So if our target roll is larger, then we want to go positive. If our target roll is negative, then we want to go negative. And so that's what we're going to get out here. We've already got something called direction. Call this roll direction. And so our current roll is going to be equal to our current roll is going to be equal to our thing. We want to clamp it. And so we've got the roll direction, we've got the target roll, got the current roll. So we want the roll direction we're going to go in, multiplied by this dot roll rate. What happened to that? Should we put it in the wrong place? Roll rate. It's in here. Yeah, there we go. Multiply the roll rate multiplied by the delta frame time so that it's not dependent on frame rate. And then we want to add all of this. Let's do the clamp afterwards because this is getting long. So current roll is equal to the current roll. Or just plus equals this even. And then we'll clamp it. Is plus equals not a thing? I guess not. Current roll, box scope variable current roll used before its declaration. I think this is... Let's just get rid of all of these things. Oh, okay, yeah. So it doesn't like the fact that I'm doing this in here. And that's fine because actually what I want to be doing is this. Spelling has gone awful. And we want to go between minus roll max and positive roll max. So we're just stopping it going past the edges. So the downside to the way this is set up right now is that if we go ever so slightly past our target, we will be in trouble. So this is going to oscillate, I believe. It's not moving very fast. If we lean, how long does it take? Oh, that roll rate is very low. Okay, let's up the roll rate. Where did you go, ship? I want to change your roll rate. Why do I not see the roll rate in there? Let's look in the code. Yeah, you're in the script. Maybe it doesn't like this. Make it 0. Did you show up now, roll rate? Yes, you did. We want to make the roll rate. Let's get a calculator. 2 pi is, well, double pi. Let's make it 6. But as close as we can get to something that makes sense. Save it. Am I there? Sorry, Michael, I didn't see your message. I'm not the Big Bang creator, but I am one of the dev team on Big Bang. And let's, test that out. The YouTube chat is a little harder to find. So there you go. You can see it kind of like fighting. But you can see now we have like a smooth transition. So we just need to fix that fighting. Whoops. And obviously the crashing and going to infinity, which is a really weird new behavior. So the reason for that jiggling is where the heck did my vehicle go? So the reason for that jiggling is that it gets to in this line we're adding the full amount of the roll rate onto our current roll. That just means that we will overshoot quite a lot of the time, and then the next frame will go back the other way and we'll overshoot again, and it'll just jiggle between those two positions where everything's overshot. So you want to limit the amount that we can do. So we've got this roll direction here, but we could also then have like roll left and do the same thing. Roll remaining and do this. And we don't care about the sign for this, so we'll do the absolute value of it, which is removing the sign. And we still want this for the roll direction. And so the roll remaining is saying like how much of this roll do we have to go left, or do we have left to go? Sorry, my brain. So we want to have like roll frame amount, and so this is the amount of roll we're going to do this frame, which is currently this value. So we want to keep this in here, but what we want to do is limit this to the amount of roll remaining. And so we could just do like a, so we have this kind of like amount, which is also the direction. So if we just remove this, this is the actual just like amount. So we can do the minimum of roll remaining and the roll rate. So what that's going to do is basically whichever one of these is larger, it will use the other one. So if our roll rate is larger than the amount of roll remaining, we'll just use the roll remaining. Otherwise, we'll use the actual calculated roll rate. And so then the amount that we want to do is the direction, so that we're going in the right direction, and multiplied by that frame amount when we add it to the current roll, and we still want to clamp it to the maximum. So that should be pretty cool. Let's give that a go. So we're in, we're turning, and we have smooth turning and no jittering anymore, which is all we wanted. You can see that as we stop going faster, we return to the thing as well, and we no longer have that like ability to spin ourselves around. So it's much more like an actual, or it meets our feelings on what a vehicle should be like, I will say, as opposed to this is what a vehicle should be like, because there's loads of vehicles around that behave differently to this, and loads of situations where vehicles will behave differently. So the next thing to look at is why our physics is going weird and going to infinity, because that is an important thing to fix. And also this arrow, what is going on with that? What's the time? 1:30. So we've got ages left. That didn't take nearly as long as I thought it would. So let's update the current task. Current task is, can I edit you? Let me edit you. It's no longer making turning better. It's fixing nan bug. That's what we're going to do now. And so the NAND bug is basically, ooh, there was some jiggly there, which is interesting. I wonder if there's just some weird frame rate thing going on. So the NAND bug is essentially we're getting stuck on something when we have a collision, although now it's refusing to reproduce. So that's always a fun one. So like that, we got stuck inside there and bounced out. And we didn't hit the bug that time, but if we get stuck enough, we get blasted to infinity. And I think we've lost our thing totally. But if we bring up the entity panel and find the car, use our F3 transform, look at thing, we can see that the car is like somewhere weird and like very close to zero and just kind of like stuck there. But our camera, and it's not yawing or anything like that, everything else looks okay, so it's a bit of a weird one. Our camera has gone completely wrong. It's like off. Everything's gone red, and everything being red means that at some stage something called like nan poisoning happened, and that's essentially when something gets moved and there's a divide by zero in there or something like that, and the result is not a number. It's like it's no longer a number that can be represented. It's an illegal operation in the maths, and because of that, or because the thing has gone off to infinity somehow, we're getting these red marks appear. And so I have a couple of hunches, because this wasn't happening before. So I think it's something to do quite probably with the way the camera works, maybe, or with the characters being in the car as well and respawning. So I'm going to look at a couple of things, trying to work out what's causing this. So where's the player? That's the other exciting question. The player is at like zero. Where are they at? They're at like a normal position. Players here, and yeah, they keep respawning and falling through the world. So that's one of the things I thought that could be kind of like, you know, suspicious. The car is all the way over here, and we just can't see it anymore. Car seat's in the wrong place. What about our particles? These represent our particles. They're in the right place. That's maybe why our car's getting placed into the right place. And you can see, okay, right, like here's the giveaway for what's going wrong with the car. It's E plus 2227 and 2228. So like orders of magnitude in the wrong place. And similarly with the car, it's a massive number. So the way floating point numbers work is that you've got this E. So like 2e to the 228 is 228 apparently, which is interesting. But that's not the right answer. So this is not doing what I think it was doing. 2e to the power. Where's the power? Power of 228. It's like this. And it just tells me it's 1 to the power of 99. So that's not a particularly useful thing to learn, but it's basically a whole lot of zeros on the end. And that causes loads of issues for all sorts of things. Like this car seat is just like blown out of the sky, which suggests also there's not a bad thing that we're doing. It's maybe a bad thing internal to the engine that is interacting with a bad thing that we've done. Sorry, I've closed chat as well. I'll open that up again. Hey, John. It's going pretty good. I'm confused about how we're measuring views on here. There's a thing that doesn't update and all of that sort of stuff. And there's much fewer people watching, I think, just because they're not on Twitch. So I'm, just doing my thing and debugging this problem. So we know what happens when we get caught in the ground and get caught in the ground for long enough. So probably the thing that's happening is that we're generating too much force to like ping our character back into a safe spot. So if we stop and start again, so we're back. And the other thing that's happening is the character's getting respawned. And we should probably disallow that. So I don't know if we have a way of turning off respawning. But that is kind of what we want. In fact, respawn at ground position. This isn't even the thing we want to disable, I don't think. Where is the thing we want to disable? It's not the username. Character movement has a kill height in it. Respawn on fall as a sticky. So it's actually that does it. And that's interesting. Because we disable the movement script. Where do we stop? So we actually do the respawn on full stuff. Okay, so we need to turn that off as well. Let's see if there's a event in here already to do that. Can set movement property. So I guess respawn on fall. Is it just called respawn on fall? It is. Where are you? Respawn on fall. So that's easy. We've got our interaction logic. And is it in here we do it? This is just where we get in and out. Oh yeah, we updated this for the driving. That's what happened. So it's on the car seat itself in this code. So we send an entity, send event, set movement property, and it's gonna look it up again. Respawn on fall. So this isn't type safe in any way at all, which means that you can make mistakes, which is why I'm being careful to check what's going on. Set movement property. I'll just make sure I've spelled that the same just by copying and pasting it to be super careful. Cool. Respawn on full false. In fact, we want to do true here. We want to turn it back on. And this is where we're disabling the movement. So we want to disable that. But this isn't the cause of our problem because our character, our car isn't, going into the wrong place. So let's just see what that does in terms of fixing our game and just save what we've done so far. Where did you go, car? So John, new stuff that we've done, it's been pretty eventful. We now have, whoops, he spoke too soon. It's been pretty eventful, he says as he drops the car off the edge of the level. You can now get in the car and it doesn't turn unless we start going at a faster pace. And we have nicer logic for just smoothing the direction change as well, which is pretty cool. And then the other bit we need is, well, the other bit we changed is just that kind of like pick up, so you can't turn unless you're going a bit faster. So now we need to try and do that nan bug again. Probably crashing into this will help. Or not. It's one of these fun ones that just kind of appears and disappears. Okay, here we go. We got stuck in there, and then we got bounced out. So we survived. And we didn't respawn, so the respawning could have something to do with it. Ah, I've driven off the edge of the level. You can dive. It's pretty fun now that we've got that sort of on there. So yeah, stop start again, because it doesn't really help us if we're not in the level. Okay, we got stuck this time. And then we popped out somewhere just under the level. So that didn't break this time. So, whoops. That was unfortunate. It's like the problem working with physics is, let's just see where that is. Where are you, car? You're just falling into infinity. So yeah, the problem working with physics is if you do what I did, which is like get up underneath it, you actually just push the thing away from you. Come back. No, I didn't mean to get out of you. Rescued it. Okay, let's see if we can repro this nan thing again. So that didn't repro it. That didn't repro it. In fact, worked way better than it has in ages. That's how it's supposed to be. That is not how it's supposed to be. Did that go to infinity, or are we just like under the ground somewhere? Yes, that broke it. And we can see in here that the car is at some ridiculously high value. And these seats have got nan values to them. But that's interesting. So that's a good data point for debugging this. I'm just going to move this window out of the way and keep it on like one of the car seats so we can see when it happens. And we know now that it's not the respawning. How did I make the physics car? Yeah, so that's a really good question. It's made, you can kind of see here, there's like these two white dots and these two orange dots. And these two white dots are just particles. So they're just like little points in space that have mass and they can move around with like forces and velocity. And they're connected together by a spring between them. And then there's a spring going towards the ground. So it's doing a raycast towards the ground, just like shooting a line down and seeing where it hits on the ground for both of them. And all of the physics is just driven through that. So when I turn, I push the two particles left and right. When I thrust forwards, I just add forces that push the particles forward. And they keep together because of the spring linking them together. And the raycasts going down here, the lines going down, they can find the ground and their springs pushing away from it. So the reason why the car tilts up when it goes up here, or the vehicle tilts up when it goes up here, is because the spring gets shorter and it's trying to get back to its like default length and it pushes it. Yeah, I'd need to add like a sit animation in there. It's hard to do right now in this thing, in this editor, because accessing the animations isn't exposed yet. So I'm just sort of standing on there right now. And then also the spring is now tilted upwards, so it pushes it back slightly. So you get like physics without needing to add a physics engine in, or rather it's a different way of implementing like a physics engine. And so what I'm doing right now is trying to figure out why it blows up, essentially. Like, so the problem is we crash into stuff and then suddenly we're like hundreds of miles away from where we started off. And why is that happening? And then like probably from the next stream we do on YouTube, we'll look at something else, because I think like we've done a lot on this and we're kind of like bumping up against the edges of the engine essentially. So when we fix this NaN thing, then we'll go back, and what was the other task I wanted to do today? Don't remember off the top of my head. We'll figure it out when we get there. But yeah, I'm just trying to get my head into like what's going wrong here. And this is the code. This is the code that does the getting in and out of the vehicle at least. And this is some more that we don't need right now. And this is the code that just does the physics for the vehicle. So it's only like 300-ish lines of code. So what I'm very suspicious about is this on collision stay is just being fired every single frame that we're still in contact. And that leads us to generate a force that's applied every tick, if I can find it. So this kind of like collision force here. So if we have a hit normal, it's going to add that collision force to our particles. So our particles are going to accelerate, 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 and then just like explode into the distance. And that's not particularly helpful. Or it is, because it gets us out of these like collision situations. But sometimes it's not doing that. And sometimes we just get stuck inside a thing, and that just accelerates this kind of like force. I also think that the normal is coming out in the wrong direction. And I did use the correction vector to kind of like try and fix that. So that might also be like a factor in why this is going wrong. Because I'm relying on like Doc Big Bang's internal collision detection stuff, and that is occasionally wonky right now. We're fixing it by implementing Bullet as the physics engine. So you would no longer have to do this kind of like create your own physics engine stuff, which is sad. Or you can still do it if you want, but we'll have more robust collision in there. Yeah, so we apply it to either A or B. So it could be that we're also doing it to the wrong end. But probably not. So we're applying the force. Then we tick. I'm just checking the tick of the particle that we're removing that force after doing it. Yeah, so we set it to 0. So every time it's applying a force, and it's accelerating one of the particles. So what we can do here is like log out that we're applying the force, and then let's log out the velocities, length. Where's my quotes gone? And the reason I'm doing this with logs instead of using the debugger is that this is like something happening over time. And so you can't really look at it in a debugger unless you could graph. Like it'd be nice, a really cool debug feature would be to be able to graph values over time. So you'd be able to see how they changed. That's definitely something we should do. Right, so now when we're flying around, we can have this open. You can see where this error was being thrown in, like the audio listener entered the camera with non-finite position. It's saying that it's got a position that is not a real number anymore. So we can drive around and I can do the thing where crashing into here probably does this. So you can see that it was applying the force, applying the force, applying the force. And we sort of popped out. And that's interesting. So it was applying the force and it didn't really do anything weird to our velocity there. So that means that although it happens when you're crashed, I also reach like a maximum velocity quite quickly there. The other thing is it's applying the force, and this is before the tick has happened, so that's maybe not a good representation. Hey, Chris, how's it going? Let's change where our logging is slightly. So now we know we're applying the force there. This is where we've ticked it. So this is our our velocity after the tick. And that is maybe a better way of helping us understand what's happening. Right, let's find something to crash into. Yeah, well, that happened much quicker than last time. The velocity is infinite. So let's pause the game and see if we can find out what happened to make it infinite. Applying force, applying force, applying force. And here you can see applying force, velocity A, velocity B, velocity A, velocity B, velocity A, velocity B, velocity A, velocity B. So it got large very, very quickly until it went to infinity. Which is concerning because it's not applying the force anymore. It's our spring, I think, causing this. Maybe. So these are frames where, like, yeah, these are frames where we haven't applied a force, but things are accelerating. Like these are getting faster and faster and faster. So maybe the direction that these things are going in is interesting. How are things in Streamerland? Things in Streamerland are fun. We're just investigating this bug where stuff explodes. And this is a really common thing that happens in physics engines, right? Like you apply these forces again and again and again, and suddenly at some point a thing snaps and you're left wondering where it broke. But here we can see that it wasn't, that we were applying this force and it wasn't here. So if we stop and we start again and we just go and add some more logging in to understand more what's going on. We don't need this F3 menu anymore because we kind of can see that it is our code that's going wrong. And we've ticked our suspension, we've ticked the spring. Probably what we want to do is inside this spring here, just log out the magnitude of this force and the difference between them. And that's the difference from the ref length of it. Uh, this chat on YouTube is hard to read. Can we make a nice river in game? Yeah, we will. We'll do some more stuff in later streams. Yeah, this is like an interesting one where I'm thinking, John. But yeah, we'll do some different stuff in later streams that isn't this technical. Like I did jump straight into like a super technical topic that involves a lot of like looking at code and debugging rather than making cool stuff. I think going back the way to making cool stuff is the right thing to do for at least streaming right now. So we're looking at the spring forces, just trying to see where this explodes. And if you're wondering how the hell does he know what to look at, I don't. I'm just making guesses. Where is the thing I crash into? I can crash into this one over here. And it saved itself that time. So this is the other fun thing about doing this sort of stuff is like your code can work sometimes and break the other times. So here we go, crashing into it. Let's go to infinity. Now if we just pause, we can just take a quick look at the logs to see like springs weren't that different. Spring force was quite small nominally there. Just kind of like stuck. So that's fine. Let's try and get stuck again. We did not get stuck. No. Are you trying to make a role-play game? Yeah, I think like making a role-playing game in Big Bang could be really cool. Are you thinking about like making like a turn-based role-playing game or like a kind of like live in-game D&D style thing where people are role-playing and you're kind of like DMing it? Madison County roleplay. Ah, okay. So like what's the game called? The Roblox game. Ooh, no. Why did that not break? Are you gonna break? No, you just fell through the ground. Well, that's infuriating. I wonder if logging is like changing the behavior. Essentially, like adding logging in like this slows things down so it can totally break things. This usually breaks stuff as well. That worked perfectly. Let's try more speed. Straight into the side of this. This is fascinating. So like ordinarily that would have totally, like the last time we did this, you'd no way of being able to be like stuck inside something for that length of time without it going horribly wrong. And all we've changed is adding the logging in. So it's still not, I mean, like it's not doing the right thing, right? But it's not just breaking and firing us to infinity. Yeah. So we're going back. Spring force gets larger. So basically what the spring does is like it's stiff, so it holds the bits and pieces together. And tries to keep them the same length. No, definitely not better in Roblox. I just know the game, like similar games from Roblox where you can like get a house, drive around, like become a policeman or like a doctor or, you know, run a nightclub, all of that sort of thing. I've got a kid who's 8, loves playing Brookhaven. That's the name of the game I'm thinking of. So adding the logging in, stop that breaking. Let's just see what happens if we take it back out again. Bet you this breaks like first time now. I think like Big Bang's a really good game for doing that sort of thing in. Like it's perfect for spending your time. Okay, yeah, it exploded that time. We pause again. Everything's infinity. So we get the same problem where the force just goes crazy. Okay. Let's add one line of this logging back in. It's just mildly infuriating. Yeah, it's a great idea to build that in Big Bang because, you know, we don't have a game like that right now. And it'd be amazing to have like a user-made game that did that. That's just... Okay, that did happen that time. So the spring force is naught because everything's at infinity. And I tried to pause the game. I did not manage it. This is where I'm like, I can't find it anymore. So applying force. The spring force is 2477. Applying force. The spring force is suddenly 20,000. The spring force is suddenly 11,000. So that spring force seems pretty high. Almost like particles A and B are getting forced further and further apart, even though they have identical velocities, which I find suspicious. Probably because I'm logging out just one's velocity. This is maybe where my brain has gone weird. So we know it's because the force, yeah, so I'm logging out particle A's velocity. So yeah, so this is what's happening. Yeah, it won't let me over. There we go. Is everybody just here now to mock me and my trying to debug math issues? Ugh. Come on, car. So I'm gonna, like, a large part of this is trying to get the... This is where things go to infinity, Rob. I didn't even know... Thought infinity was just there in floating point numbers for the fun of comparing them to things. I didn't know that the engine, the math engine, the number floating point representation, if you get too much error, will eventually go totally wrong and spit out infinity. There we go. Now we broke it. So it's basically you got to have like enough time stuck inside something. And it should be way more obvious what's happening now I'm logging out the right stuff. Going up, going up, going up, going up, going up. Here we go. Those are some hefty velocities. I like the way the spring force, like, you know, the spring is doing what it's supposed to be doing. It's eventually calming down. No, it's just accelerating. The velocity for B goes to infinity Beautiful. So we're just we're basically applying a force, applying a force, applying a force. And the spring force doesn't seem crazy to me, and the velocities are within the realms of not insanely different to one another. And then we get this, where B, the velocity of B, goes from one tick to the next, just goes enormous. So the next question is, who are we applying the force to? So we're getting closer, steadily working out what our code is doing, which is always good. I'm just going to be super lazy and just cut this out and chuck it in here. We're applying force to A, we're applying the force to B. Right, let's get this happening again. We're running the game. Jump in and try and kill ourselves. I love it when it actually works. That's, perfect. There we go. At least that happened quickly this time. So let's find out where it died. How does it log out so much stuff before we even get there? So here we go. This is the thing. Okay, so we're applying the force to B. We've got the spring force, the velocity, applying the force to B, the spring force, the velocity, applying the force to B, spring force, the velocity. It's going to do B all the way through. And then it just explodes. So essentially, in one frame, it does this massive boost of acceleration. So let's go look. How do I edit my game screen on the game? Black Fricey Gaming. You're gonna have to ask like the question with a bit more detail about what I'm doing that you want to know about. How do I edit the game in the game? If you make a new game, you can click the edit game button, and that lets you just go in and you have the full game editor. You can move stuff around and play about with the values in it and all of this sort of thing. So you can just make a game in .Big Bang, edit it whilst you're playing it. It's kind of why .Big Bang is super cool, because the editor's just built straight into it, and it lets you do what you like when you want to and try things out. I've saved the camera off in a broken position again, which is kind of annoying. So what was it I'd done? So it worked out that at some point particle B had gone crazy, and this is in a loop. So we're going through this loop, and it's just having an enormous amount of force applied to it somewhere. So we need to work out like why and where. So I'm going to log out 2 additional pieces of information. In the particles tick, we are working out what the acceleration is. So my bet is that this force is just really high. Either that or something really strange is happening with drag. But my bet is this force is really high. So I'm going to log out in here. I think we named things at some point. I'm just going to do that quickly in here. And I'm just doing this to make debugging it easier, really. so that I can tell which particle it is. And then when we make it, I need to go and give them a name. A and B. And where were we? In the particle. So if this dot name equals B, console.log adding force force.length. Because I suspect somewhere there's just a giant force being added, because we're adding the same amount of force each time, and we set this internal force to 0 every time we update it. So in one frame there's just like an insane amount of force being added. And then we want to do the other thing here, which is like, let's just have another example of a giant number, essentially. And that's just so that I can see that, yeah, it is like in this tick that this giant number appears. And I'm going to do it with the acceleration because that's always fun to look at. Probably should do it here. And yeah, let's stop and start the game again. Reproduce what was going on. Did I answer your question, Black Pricey Gaming? Well, that exploded nice and quickly. That's always nice. The other thing that concerns me is that it's sort of like random how that actually goes through. Well, now it's even weirder, just in terms of what it's logging out. And I can't find where this started. It's logging too much stuff out now, maybe. Or I didn't pause the game quickly enough. This is one of the issues with using like console logging as a debug mechanism. If your console's spamming stuff out of it, it's not very handy anymore. Oh, no, we survived. Got flung back out again. I wonder if we just go into it really slowly. That was super weird. So I think there's like culprits to me right now are, okay, is just the springs generating enormous forces, which it didn't seem to be. It didn't, like, it seemed to be generating like a very much constant amount of force. Adding force 4,000. Adding force 0. 4,000 is a suspicious amount of force. Adding force 0 is also a suspicious amount of force. It's the spring force is 0, so it's just adding that in. Acceleration was 50. Both of them seem to be called B. Oh, I've not. It's topping out how much console logging I'm getting now, even when I kill it, which is interesting. Right. Let's do some more. So I'm logging this out at the wrong point. There, that can remain ugly with random spaces in it. So I'm only logging out. Let's just write to B so I know what's going on. To B. Needs a space. I might need to reload the page because I might have broken DevTools. Because it doesn't seem to be keeping enough of a history to see what's going on. So go in and crash. That was amazing. It's interesting that it's also like once you get stuck into it, feels like it's doing the wrong thing. Let's go in here. That's a nice. So if we just pause a second. So we're adding 2, we're adding 0.02, we're adding a 99.8, we're adding 0, we're adding a 50, we're adding a small amount of force. This last one is probably the, well, this last one is the drag. And these will be from the suspension. This will be from the spring, this is from the spring. This is from the suspension. Let's add some more logging just so we can see what stage we're at in all of this stuff. So we can kind of see, we know we're logging out what the okay, yes, doing both things. But we just know what segment of the update we're in, essentially. And let's try it again. It's definitely one of those things where putting logging in affects it because it's changing frame rate, I think. Or we just happen to be getting super lucky sometimes. Shooting up into the air. If we just pause, we can go look at the logs when we're doing these forces. So we're doing suspension A, we're doing suspension B. So this is the suspension force. This is the spring force. I wonder what this force, oh, this could be the, I wonder what force that is. So we're not logging out anything here because suspension A isn't logging out the forces it adds. And then we're adding 2 sets of forces here. Then we're doing the tick. Then we're doing the force from drag. And then it becomes an acceleration, and then we're changing our velocities. So am I just ignoring an additional force that I didn't think about? So we do the drag, we do gravity and the acceleration in the gravity. This is calculating the force. Yeah, it's the damping from the spring. That's what the additional forces are that I'm seeing in there. Cool. So we kind of know what everything is. We just need to reproduce the problem. And I could just combine those 2 sets of forces together, the damping and the thing, and apply it once. but it's doing roughly the same set of operations. Is that interesting stickiness, which just says that something I fixed is not fixed. I think I've hit that same case where everything is fixed. Somehow we're not going fast enough. It's fun to watch though. You can see like it's just sort of sitting there, not doing anything. Oh, you mean like changing how it looks? If you click on the mood button, you can change the parameters of how everything looks. And so there's some preset ones here, but you can also go into the options and configure everything to whatever you'd like them to be. So you can change the setting. That way, sun, sky, all these sorts of things. You can also access all of that through the code as well. Is that helpful to you? So yeah, we've got too much logging now, I think. That's what I'm going to say. We're happy that the spring force doesn't go crazy before everything else goes crazy. So let's remove that out. And I guess there's going to be a large force added at somewhere. Keep that in there. We take this out. And we'd also worked out what the mysterious things were. They were the damping of the spring. And we know when each tick's going past. So we just have the forces that are getting applied. You can count through them and kind of work out where we're at. With our newfound knowledge. Wow. Okay, that was another way of getting that to happen. So maybe the frame rate's too high. Is what we've discovered there. And again, it's not giving me the full log. So I'm annoyed. And I'm just going to reload this up again. Let's see if we can get it to happen now. It's very interesting that like just sometimes that's robust, sometimes it's not. And somewhere there's like a case that just causes this giant number to pop out. Maybe it's when I've clicked on it. I know that's a silly thing to think about. Maybe. Is this published in public? Yeah, let me send you a link. There you go. Hey, Didier. How's it going? Welcome to the stream where I'm debugging weird physics problems, or at least trying to. It's behaving itself now. I'm just flying out into space. Yeah, so one of the things I'd like to know from people is like, what sort of things would you like to see me make on stream? This is just, I'm literally turning up, and that did it that time. I'm literally turning up and just making stuff. And so I decided to do this all by myself. That is incredible. I can no longer get all of the messages I had. Why is it topping out at 1,000? It's extremely aggravating. Ah, psych. Yeah, good to see you. So getting topics from people of things they'd like to see me make. Like Ashley's been making the cat game. I can do other things. I was thinking about maybe just doing like making a hide and seek game, or like picking small little things to build. Like how do I make, the Black Friday Gaming wanting to make like a role play kind of game, like maybe doing a way of changing your occupation, that sort of thing. Making a house that you own, like bringing that into the game. We can do some small things like that, or we could do like a bigger thing, like maybe making a hide and seek game. Make a video about the edit screen in the future. We have them. If you look on our YouTube, there's a. I want to know what the category is. Could just go onto our YouTube and show you. YouTube. So if we go into the .Big Bang channel, you can see we're live right now making RAD physics vehicle in .Big Bang. But under getting started, we have a tutorial for the editor and for the voxel object editor, and also help to start coding. And then we've got a longer tutorial for how to build an obstacle course, which goes through a lot of details about how the editor works and how to make things in it. And similarly, we have these 2-minute tips, which will be expanding, which will go through more of these things as well for you. So you'll be able to like learn. You can learn already a lot about the editor, but we'll be expanding those videos for you. Live streams are more about like a chance to show how stuff gets made and see how they go. We can answer questions in there. Also, if you join our Discord, if somebody could pop a link to Discord into the chat, or in fact, I can just do it. I believe that is correct. If you just click that link, you go into our Discord. There's a creator space channel and a scripting channel. And on Wednesdays and Fridays, we do an office hours. And that's just a chance to like show up and ask any question you want about how something works. And there'll be a community engineer there that can give you an answer. Like, I want to know, like, how do I go and edit this like thing? How do I add sounds on? Or how do I don't know, just how does the transform tool works? They can give you an answer to that. And also, if you've got a game you've got made, you can just drop that link to somebody, and they can go in and look at the game and show you live on your game what to do. So it's super useful if you've got something in progress and you want to learn how it's working. I've forgotten what I was doing now. Oops, I'm trying to open DevTools in the wrong thing. Oh yeah, I was getting annoyed at this. That is what I was doing. So for everybody else that was here earlier, I was able to see much more detail here. And it wasn't like topping out. I want to know if it's just like got group similar messages turned on, so it shouldn't. I feel like we've accidentally filtered stuff. Can we just do the inside one? That doesn't really help. I feel like I've broken Chrome, is what I feel like. But that's interesting. One more go at it. Ooh, I like the little bounds around the object now when you've got them selected. That's very cool. Well, in fact, all the objects show their bounds on their corners now. That is quite cool. Or I've broken something. Well, now I've stuffed the camera right into it. Like, maybe we can see some of that now. I thought I removed the adding force logs. No, I didn't. I kept those in. Adding force to B naught. There also seems to be much fewer forces being added all of a sudden. Did I make an this is the example game right now. I made an older one. So I made like a game in November that was just basically a similar thing, but I didn't do it whilst I was streaming, which is kind of where the inspiration for this came from. And kind of the point of that was just to test out the editor and play about with it because we're releasing a new version of it. So I had a test game for that. What I think I'm going to make, like we've got a terrain system in progress right now. So all I was thinking of making is like this game within our terrain system. I think doing this has taught me that there's maybe some other bits and pieces to fix. So let's just save that. Like I did have logging, applying force to A, applying force to B. So that is still there. So yeah, didn't have those in there. Let's see where we're at with. Okay, so this is logging loads and loads and loads and loads of messages out. And they stay there when I hit pause. And they stay there when I hit stop. And they come back when I do that. Okay, seems that that's working. I'm not going to close the log down whilst I do this. So we can watch what happens. This is going to make things run much slower, which, given the nature of this bug, might make it pop up more easily. No, let's. So it's definitely. So there is an issue with the capsule collision that we're using here, that when it gets stuck, when it goes too far inside of things, it starts giving bad results out. So I think it could be that as well. So there we got super pinged into the sky. It's also like we've made sure that our physics is locked to 60 Hertz. But the collision just goes as fast as the game engine goes, which is very dependent on frame rate. There we go. So we managed to get it to break. And we got all the logging messages finally. Don't know what I did that fixed that, but that is what I was waiting for. Now we're just going to go up and find where we didn't have 4,000 and 0. I wonder what that 4,000 force is. So there we have our velocities and forces. Can scroll through and we can see where it goes crazy again, which is interesting. Yeah, and like you could basically make the level that I've linked there if you hit the remix button, which is around. I don't think I have it on mine because this is mine. You could maybe click save as on there. You'd make your own version of it and you can go and play with it and add, like, jumps in, make a track to drive around, do whatever you like with it. So you can see here's some enormous forces that are coming from the suspension by the looks of things. Pardon me. So adding force to B, 5,000, which is great. And there's another 5,000 here. Which is also interesting. I will track that down. And you can kind of see like the velocities are staying kind of cool. This seems okay to me. And then we're adding force. We're adding a force of 25,000. When we were adding a 5,000 before that. That's where we're getting our weird number from, at least. And there's a 0. 2,000. Okay. So we're getting closer. We know that there's a weird force coming in there. We also know that there's this force and this force, either side of this applying force to B. It could just be the acceleration force, I think. And this is 5,000, 5,000, 5,000, 5,000, 25,000, 20. Wow, that's like 1, 2, 3, 4, 5, 6, 25 million it suddenly goes for. And then on the next frame, we got the 25 million in there. On the next frame, it's no longer in collision, which is good. And it's no longer adding that force, but it's absolutely caused these other forces to go ballistic. So that is the issue. Right there. And if I'm right, that's a really interesting occurrence, because it's not not my code, he said confidently. Applying force to B. Anyway, it's the immediate force that's added after that. And I'm absolutely going to say that that is this force calculated here. So we're getting the normal multiplied by the collision force. And we're either applying it to A or applying it to B, depending on which one's the closer to that collision position. So this hit normal is coming out as a really large number, even though we have supposedly normalized it here. Normalizing something is making it a length of 1. So that is a suspicious thing. And here you can see we're applying the engine force. So the very first thing is the engine force getting applied. And then we're doing this. So when we're applying it to B, let's just log out the hit normal as well. Because I bet my toothpaste that this is like a value of like 3 or something. Because the maximum this should be is 5,000. So 25 million means it needs to be a very big number. I'm just going to do this here, so I'm not changing it. But that's an interesting one. Oh. Whoops. And now I've broken it in a different way by running into the back. That is my fault. Probably should make it so it ignores players or something like that. Right, let's go crash. Don't just pop us back out again. No. Ah. Are we logging properly? I'm going to keep this open because that did seem to help. All right, let's line ourselves up. And crash. Explode. No, you didn't explode. So I think one of the interesting things is it's probably very dependent on the engine having a moment as well and getting those kind of like stars to align in the collision. So now it's working pretty well. Let's stop and start again and see if we can properly break it. Clear out the console. Got 10 minutes, or 15 minutes to try and work out where this is coming from. Otherwise, I'm going to have to do this on my own time. Okay. Come on. No. Because you can see it sort of bouncing up and down as well there. It's very interesting. Mama is downstairs, Aldrin. I love the fact that this just doesn't break sometimes. Usually straight after I'd chuck this in. I believe we're getting sensible values out for that. Maybe I'll just try changing what it's logging and seeing if that convinces it that it wants to happen. Gotta just do the length of it, because then we'll be able to see if it's a sensible length or not. But yeah, I mean, that is like super suspicious. And I guess it's only like if you don't open it up, then it's nice though that it's sometimes robust. Ish. Take off into the sky. Fly through the ground. So some of that's happening because we just don't have like our collision resolution force is like small. It doesn't scale up and down. And if we just pause, then we can go back up and we can see I did not pause. We can go back up and see that whilst we were in collision, if we can find when we were in collision. Here, like for example, it's a length of 1, it's 0.999, which is close enough to 1 to be 1. We can try removing some of the other bits of logging as well, because we know, or we're pretty sure now, what is causing the problem. And if the logging is what's making it more robust, we don't care about this anymore because we know when it explodes. Is that the last bit of logging that we have in there other than adding the force in? We could even just take this out. I'm just going to comment this out though rather than deleting it. So now there's much less stuff being logged out. Yeah, so yeah, it does just give you It's like a you need DevTools open sort of thing. We're applying force to B 1. Does that mean B is the closest one? So we did apply the force to A there. But it worked fine. So maybe not, having too much logging is a bit of an excuse in a way for why this isn't reproducing. Although it was reproducing much more easily earlier. It also probably removes so much logging now that I need to add it back in again when I want to find it. I'm just going to drive around a bit, see if I can figure out. Pounced off the ground there. It's a fascinating thing though, like there's just a point where it explodes. And you never hit it when you want it. Like you know exactly now why, or roughly why the problem is occurring. You just want it to occur so you can watch it happen. But I'm really confused at how that number ends up being so large. So that'll be fun to answer. And the reason the vehicle's getting stuck there, the way our collision system works is it's detected a collision and it's put it into the last good position. So the particles are carrying on. Like a more robust system would be to do raycast for all the particles, which is, something I think I'll probably consider. Whoops. Right, let's just do one more bit of code inspection before we do some wrap up on this, because we have not fixed this problem, but we have done a lot of work in diagnosing where it happens. So what we know from logging all of this information out is that we were applying the collision force to particle B, and the very next log that we got when things went sideways was that we were applying 25 million units of force rather than 5,000 to B. And basically that force is calculated from this hit normal multiplied by the collision force. So either the collision force value has gone up a lot and then just gone back to its normal value again, or the hit normal is longer than 1. And so my guess is that the hit normal is longer than 1 by quite a lot, or some other way it is not being reset. So we do this multiplication and then we multiply it again. So we're not resetting the hit normal. So we set the hit normal to 0 here. Okay, this is great. We have answered our own question. So is there a way that that cannot be set to 0? Doesn't look like it. Does not look to me like there's an early out in this. But maybe what we should do is, after we've applied it, set it to 0. And then just make sure it's 0 every frame anyway. The only way it could not run into this is if one of these things had disappeared. Hi, Ulfrin.
Where's Mum?
I don't know. Downstairs, probably. Sorry, I've got a small child climbing on me now. The interaction arrow, yeah, I have no idea why that's working that way. I think it's something to do with the vehicle moving around and the fact that it's putting this thing into screen space. So I don't quite understand it myself. So the other thing it could be, if it's not this apply force, the very next apply force is to do the steering. So it could be a giant steering value. But I don't think that's the case looking at the information that we have here. Because the velocities, this is just calculating how much it's going to be between 0 and 1 for just the speed turning factor here. Could be the suspension, that's certainly thing. It could be the spring, since we take that next. But again, didn't see any weird differences in velocity or anything like that that would cause that to explode. And we definitely know this was happening and then this was happening. So, right, let's just save what we've done and do one last attempt at like seeing if it breaks. If it doesn't break now, we may well have fixed it with that hit normal reset after it's been applied, because that's when we really want to make sure it's 0. And here the particles are driving through. It popped out the other side. It seemed okay. Here we got a big bounce. I wonder if you can see that big bounce in the logs. And if there's any like weirdly large numbers. Doesn't look like it. Looks like it's all okay. So I think that guess that I had, so just in case it wasn't obvious, the guess is that essentially if we get back through here, and this is okay, yeah, this is definitely how it happened. So this is the way it works. We have one frame of dot big bang being called, and then we have between 1 and I don't know, like however many ticks need to be called internally for one frame of the vehicle physics simulation to be run. And we're doing our collision force application inside that second loop of ticks. So the thing that causes this bug is when you're tunneling through everything, you have a frame where there is like 2 or more subframes being run. So normally everything's running fast enough that there's one game frame being run and one internal frame being run, and so they're just running together. And then you reach the point where like occasionally where like 2 internal frames need to be run for one game frame, and that, because the hit normal was only set to 0 outside of this loop, essentially to basically catch the next frame, it was then multiplying. It was still doing, hit normal was still set to the right value at that point, so it was still doing all of this stuff, except for every single time it got through this loop, it was multiplying hit normal by 2,500. So if we get a calculator out and do 25 million divided by 2,500, it's like 10, well, it's not 10,000 times. It goes in 10,000 times. What is the actual calculation that I want to do? It's like how many 25 million, how many times do you have to multiply 2,500 together? Because it's squares, like 2,500, I guess it's probably 10. 2,500 multiplied by 2,500 multiplied by 2,500 is equal to now I've multiplied it by 3 times, so it's just 2 frames. 2,500 multiplied by 2,500 is like already 6 million multiplied by 2,500. Whoops. is already an enormous number. So it's not 2,500. I guess it's 5,000. It's 5,000. 5,000 multiplied by 5,000. 25 million. So it does 2 frames, and then the second frame it is 25 million. Square root is what I was looking for, and I was also using the wrong number. So this fix here gets rid of that ridiculously large force, and because it's added a ridiculously large force, it moves one of the particles really far away from the other one, and then because of that, and because of the spring is so stiff, we would need a much smaller time step to sensibly apply these, so it just ends up in this position where everything's going crazy and explodes. So we fixed that now. We actually did it almost on time, which is nice. I'm gonna have to run because I have to chat to Charlie now, but thank you very much everybody for watching, and I will see you next Wednesday, hopefully to do something more interesting.